Hi guys, hello from my makeshift classroom at home. So of course we'll try to get the quality as good as we can, but it won't be the same as our live class experience. I know this is a very difficult time for all of us, but we'll get through this together, so don't worry. I'll try to put these videos up on a daily basis, and there's some technical difficulties that emerges that we may not know about, but as long as electricity is going, the internet is going, I'll try to put these up for you so that you have it comes as close to a classroom experience for you as possible. Okay, so in our last class, I know it's been a while, but if you remember in section 7.1 we covered rational expressions, which are simply just fractions that have variables in them. And the variable expressions are simple: polynomial on the top, polynomial on the bottom, or in the denominator. So, and the denominator should not be zero. Then we learned how to simplify them by factoring and cross-canceling. And we also learned how to multiply and divide rational expressions. So we're going to move on to adding and subtracting rational expressions. So that's what we're going to take a look at in this video. So section 7.2, adding and subtracting rational expressions. The generic term that involves both of them is called combining. Okay, so if you remember, the rule for combining like fractions, which are simply fractions with the same denominator, is very simple. If you recall, it's just as simple as a over c plus b over c. So here we're combining two fractions, and if you notice, the denominators are the same. In that case, the rule is simple: keep the common denominator c and combine the numerators. And this works whether it's plus or minus. So whether you're adding or subtracting. Same way here, keep the common denominator, just subtract the numerators. So we'll look at some examples in a minute. Give me a second while So here's a simple example with just constant fractions. For example, let's say we have 3/8 plus 1/8. So as you know, that is an example where both fractions are just constant fractions and the denominators are the same. So what we can do, we just keep the 8, we go ahead and add the 3 and 1, and we get 4/8. As always, the final answer that we present has to be in simplest form, and as you know, that's a reducible fraction. So we know that 4 goes into 4 once, and it goes into 8 twice. So we end up with 1/2 for our final answer. And that's what we're gonna write, into the MyMathLab as well. Or, for example, you can do the same thing with variables. So for example, let's say you have a over a plus b over a plus b. Notice once again, even though these are letters instead of just constants, we do have the same denominator. So we can go ahead and keep that common denominator and combine the numerators. And now we notice that we have the exact same expression on the top as we do in the denominator, so we can cross-cancel those and get 1 for the final answer. So the same works with subtraction. So let's say you have the 3/8 minus 1/8. Notice we're going to keep the 8, subtract like that, 3 minus 1, so we end up with 2/8, which once again we can reduce to 1/4. Now, if we subtract those two, we have a over a plus b minus b over a plus b, and this time we'll go ahead and keep the denominator and subtract the numerators. And this time they're not the same. So, and as you know, we cannot cross cancel the a's because you know we never cross cancel terms. So in this case, we're actually finished because there's nothing else we can do. We can't cancel the b's or the a's, so we just box it and leave it as our final answer. So, as another example, consider two x over x plus 4 plus 8 over x plus 4. Okay, at this time I want you to go ahead and pause the video and then try to solve this on your own. When you finish, come back to the video. And as you know, now that you're back, you should have gone ahead and combined the numerators, and again, we have to make sure to simplify before we type in an answer. If you type that into MyMathLab, you're going to get the red X because that's not fully simplified. And as you know, here we can factor the numerator. Notice that we have a common factor of 2. We factor it out, and that leaves us x plus 4, right? Just divide each term by the common factor to know what needs to go in here. And we go ahead and have that in the denominator, and this time, since all of x plus 4 can be cancelled with that x plus 4 factor, we can go ahead and do that cancellation, and we end up with 2 for the final result. So let's try one more example. Okay, go ahead and pause the video and do try that on your own first. Notice that you will be able to combine these two fractions because they do have the same denominator. Go ahead and pause, try to do it on your own, then come back when you are finished writing it down. Okay, now that you're back, you know that we can keep the common denominator, y squared plus y minus 2, and we go ahead and combine the numerators. So when we go ahead and combine those, we end up with 3y minus 1 over y squared plus y minus 2. So even though there may be no simplification possible, we always have to try. So we're going to go ahead and try to factor the denominator. And if you recall, we need two items that when we multiply we get y squared, so y, and two numbers that when we multiply we get -2. That seems to be pretty easy. However, we have to make sure that the inner product, which is positive 2y, and the outer product, which is negative y, add up to positive y, which they do. So we have 3y minus 1. We're simplifying the top. Notice nothing further can be done, so we leave it there. And we go ahead and box the answer. So that is the result that you should have gotten. Okay, now try the same example we just did, but as a subtraction. So write this down, 2y minus 1 over y squared plus y minus 2 minus y over y squared plus y minus 2. Go ahead and pause the video and try this on your own before you continue. Okay, now that you're back, you know that the first thing we should do is go ahead and keep the same denominator and combine the numerators, but this time it's minus y. So notice if you simplify the numerator, you end up with 2y minus y, which gives us y minus 1 over y squared plus y minus 2. Just as we did in the previous example, we need to go ahead and factor the denominator to see if we can do any legal cross-canceling of factors. So just as we did in the previous example, this is going to factor as y plus 2 times y minus 1. And we can see this time that this binomial factor can be cross-canceled, leaving a 1 on the top and a 1 on the bottom here. So overall, the final answer will be 1 over y plus 2. So notice that a subtle change in the problem, just changing the plus to a minus, gave us the possibility of simplifying further at the end. So this is the situation with like fractions. Very simple. Keep the denominator, combine the numerators, and then once you've done all the combining, see if you can factor and cross-cancel at the end. And if you can do so, then you should, and you will be finished. So the more interesting case, of course, is when the fractions are not alike. So how do we combine fractions that are not alike? Well, we don't combine them when they're not alike. We have to first make them alike. That's when, if you remember, the notion of common denominators comes in. So let's say, for example, we have a simple example with just constants. Say 1/2 plus 1/4 to keep things really simple. Notice that here we can't just go ahead and combine or anything like that. We need to first make both of these denominators the same. And of course, with 2 and 4, the LCD, or the least common denominator, is very simple. It's just 4. So we're going to try to make both of these 4 so that we can combine them. Now, this denominator is already 4. We don't have to do anything to that denominator. But this denominator, remember, we have to multiply by 2 so that we can make it 4. But in a fraction, whenever you do something to the denominator, you have to do the same to the top. So we need to make sure we multiply the top by 2 as well. So now notice that both denominators are the same. They're 4. So we can go ahead and now combine the numerators. So we end up with 2 plus 1 over 4, which is now simply 3/4. And there are no common factors, so there's no more canceling that's possible. So that's our final answer. And of course, we can do exactly the same thing if we have denominators that are variables as well. So let us first review the notion of the least common multiple. Okay, so let's start with a real simple example of finding the least common multiple of, say, 8 and 40. Okay, so actually let's make it more interesting. Let's make it 18 and 40. So now we're just going to go ahead and do something that we're familiar with from the previous lessons. The best way to do that, you can either guess it, or if you want a more systematic approach, you can go ahead and find the prime factorization of both of them. So here's the prime factorization of 18. You know, we have 2 gives us 9, and then 3, 3, 3, 1. For 40, we start with 2, divide, that gives us 20. Again, 2 goes into it, and you get 10. Once again, 2 goes into it, we get 5, and then 5, 1. Notice that here we have the prime factorization, which means on this side of the line, we should only have prime numbers, and the same for 18. So notice that we can write 18 as 2 times 3 squared, and we can write 40 as 2 cubed times 5. Now, when we were looking for the greatest common factor, we went through a similar process, if you remember. But for the GCF, in fact, just to remember, for the GCF, what we did is we multiplied even though we're looking for the greatest common factor, we have to multiply the lowest power of all the numbers that we see that they have in common. In this case, the only number that they have in common is 2, the only factor they have in common. And the lowest power of the 2 that they have in common is 2. So the GCF is simply going to be 2. For the LCM, on the other hand, the LCM, remember, has to be a number large enough for both of those numbers to go into. So if we want to look for the LCM, we shouldn't only look for common factors, we have to look for all the factors, and not the smallest power this time, but the largest power. So we're going to take the largest power of 2, which is 2 cubed, and the largest power of 3 that we see, which is 3 squared, and then multiply that by 5. So we're going to get, that's 8 times 5 is going to give us 40, times 9 is going to give us 360. So that's what we call the least common multiple of 18 and 40. In other words, the smallest number that will go into both 18 and 40. I want you to do a similar analysis and find the least common multiple of 36 and 40. Okay? So go through a similar process and find the least common multiple of 36 and 40. Since you have to go through all the work, also find the GCF of 36 and 40 till we come back. Okay, so you were finding the LCM of 36 and 40. Alright, so if we go ahead and look at the prime factorization of 36, we start with the smallest prime that goes into it, which is 2. Divide, we get 18. Again, 2 gives us 9, and then we have to go to 3, which is the smallest prime that goes into 9. We divide and get 3. Finally, 3 is prime, so the only prime that's going to go into it is itself, and we get 1. Once we reach this 1 on the right side, we're finished with the prime factorization process. So there's the prime factorization for 36. For 40, we have to start with 2, and then we divide, we get 20. Again, divide by 2, we get 10. We have one more 2 in there, which gives us 5. Finally, 5 is prime, so 5 is the only prime that's going to go into it, and we get 1. So if we write the prime factorization of 36, we get 2 squared times 3 squared. And if we look at the prime factorization of 40, we have 2 cubed times 5. And if we want to find the GCF, remember the process for finding the GCF, multiply the lowest power of common factors. You remember that process from before. And if we do that, notice that, again, the only factor in common is a 2. So if we go ahead and take the lowest power of 2 that they have available, it's 2 squared. So there's the GCF. For the LCM, the process is different. You multiply the highest, not the lowest, but the highest power of all, not just the common factors, but all factors. So when we do that, notice that the factors are 2, 3, and 5. So the highest power of 2 that we see is 2 cubed. And the highest power of 3 that we see is 3 squared. And the highest power of 5 that we see, once we have done the prime factorization of both, is 5. So here we get 8 times 5, which is 40, times 9, which is 360. A similar LCM as we had before. So that's the process involved. So when you look at, here, this is going to be a nice visual for the two numbers 36 and 40. There are two quantities related to these numbers that we're interested in. One is the largest number that goes into both, and that's what we call the greatest common factor. See, we just saw that that is 4. And then on the other extreme, we have the LCM, which is the smallest number that both of them go into. So the LCM, we have found out, is 360. So what does that mean? That means 4 goes into 36 perfectly, and you know that's what? 9 times. It also goes into 40 perfectly, which is how many times? 10 times. On the other hand, 36 goes into 360 perfectly, and you know that's what? 10 times. And 40 goes into 360 perfectly as well, 9 times. So these are the two quantities of great importance when it comes to any two numbers, or any three, doesn't matter how many, any number of numbers, because when we have to find the LCD, we may have to find the LCM for more than two numbers. So that is the process that you're going to be working on as far as finding the GCF and LCM. So next we're going to look at finding the LCM for variable expressions. Okay, so now let's take a look at the LCM for two variable expressions. For example, let's find the LCM of 25 x cubed y squared z and 15 x squared y cubed z squared. Okay, so the process is exactly the same as it was for just regular constant numbers. We're going to multiply the highest power of all factors, but only after we have written both expressions in fully factored or prime factored form. Okay, so when it comes to the variables in this case, that's the easy part. They're already written in factored form, prime factored form. So the only thing we need to worry about is the numbers. So we first find the least common multiple of 25 and 15. To do that, we go ahead and find the prime factorization of 25, which gives us 5, 5, 5, 1, and the prime factorization of 15, which is 3, 5, and then 5, 1. I don't know why I drew that line. I didn't need it. Okay, so basically we can write this now as 5 squared x cubed y squared z, and we can write this one as 3 times 5 x squared y cubed z squared. So now both expressions are in fully factored form. So basically we're going to follow the same procedure. We're going to multiply the highest power of not just the common but all factors. Remember, we're not finding GCF, we're finding LCM. So we can see by following this simple procedure, we're going to take the highest power of each factor. We'll start with the numbers, okay? And notice there's a 3, that's the smallest constant. So the highest power of that 3 that we see is just 3 itself. The next factor is 5. We notice that the highest power of 5 that there is 5 squared. So we go ahead and take that. Now we move on to the variables. Notice we have a common factor of x, and the highest power of x that you see is what? X cubed. For y, it's going to be y cubed. And for z, it's going to be z squared. We're almost finished. We're just going to clean it up by multiplying these out. So that's 25 times 3 gives us what? 75. And then x cubed, y cubed, z squared. And therefore, we now have the least common multiple of those two variable expressions. Okay, so let's go ahead and try another one. Let's go ahead and find the LCM of 36u v cubed and 20 u squared v squared w squared. Go ahead and pause the video and try to find the LCM of these two expressions and then come back to the video. Okay, so I'm hoping you started by finding the prime factorization of both 36 and 20. So for 36, we start with 2 as the lowest common, lowest prime number that goes into 36, and we get 18. We repeat with 2, that gives us 9. Now we have to move on to 3, that gives us 3, and then another 3 gives us 1. For 20, we start with 2, that gives us 10. We go ahead with 2 again, that gives us 5, and now 5 gives us 1. Okay, so basically we have 36, which we can write as 2 squared times 3 squared. So we go back up here, we replace 36 with 2 squared times 3 squared, and we don't change the uv cubed. For 20, instead of 20, we're going to write 2 squared times 5. And then u squared, v squared, w squared. So now it's time to find the LCM. We're just going to follow our simple procedure, which is multiply the highest power of what? All factors. So notice that we do have a factor of 2, so the highest power of 2 that we see is 2 squared. The highest power of 3 that we see is 3 squared. There is also a 5, so times 5. Now we take care of the variables. So for u, notice the highest power is u squared. And for v, the highest power is v cubed over here. And there's also a w squared. Notice if we were finding the GCF, we wouldn't bring the w in, because there we multiply the lowest power of common factors. But this is the LCM. So you have to multiply the highest power of all factors. So in this case, we're going to need the w squared as well. So that's pretty much it. We just need to multiply that out to write a nice simple answer. So notice that 4 times 5 is 20 times 9 gives us 180. and then u squared v cubed w squared. Okay, so there is the LCM right there. So the next thing we'll do is we'll look at a couple of expressions that may involve more interesting types of factoring. Okay, let's try to find the LCD of these two expressions. X squared minus 2x plus 1 and x squared minus 4x plus 3. Okay, so the procedure is going to be the same, but this time we have to find the factorization of two variable expressions. So that's exactly what we're going to do first. So notice that if you factor x squared minus 2x plus 1, depending on the system that you use, you can just use the big X or any method that you like, and you're going to realize that you're going to end up with x minus 1 times x minus 1. Notice first times first is first, last times last is last, and the inner product, which is negative 1x, and the outer product, which is also negative 1x, combine to give you the middle term. So that's how you know you've done it correctly. But when you get a situation like this, make sure you write it as a power if they're both the same, the factors, and you end up with x minus 1 squared. Now, let's go ahead and factor x squared minus 4x plus 3, and notice that we end up with x minus 3 times x minus 1. Let's do a quick check. First times first is first, last times last is last, and the inner product and the outer product, they add up to the middle term. So now we have the prime factorization of the first expression, which is x minus 1 squared, and the second expression, which is x minus 3 times x minus 1. So now to find the LCM, we're going to follow the same procedure. We're going to multiply the highest power of all factors. So notice the factors here are x minus 1 and x minus 3. The highest power of x minus 1 is x minus 1 squared. And the highest power of x minus 3 is just x minus 3. So just as simple as that, there is the GCF, the LCM of those two expressions. Let's try to find another one. So I'm going to write one down. I want you to find the LCM, and I want you to pause the video and try it first before you unpause the video. So find the LCM. I called it LCD here, it's actually LCM, but that's because we're going to be using these to find LCDs anyway. So find the LCM of m squared plus 5m plus 6 and m squared plus 4m plus 4. And also, this time we're going to do 3 expressions, 2m plus 6. So go ahead and pause the video, and before you do, just go ahead and factor each and then follow procedure. Multiply the highest power of all factors. Go ahead and pause the video and try this before you come back to see how I do it. Okay, now that you're back, notice we're going to start by just factoring each of these 3 expressions. So the factorization of the first one is very simple. You get what? You get m plus 3 times m plus 2. Always do your 3-step check. First times first is first, last times last is last. The inner and the outer products, they add up to the middle term. Must do your 3 checks, otherwise you're not going to get these right most of the time. So we'll go ahead and find the factorization of the middle expression, notice that one is going to be m plus 2 times m plus 2, which we will represent as m plus 2 squared. Remember, because we're going to be multiplying the highest powers, it's important that you represent this as a square. And this one is easy. There's just a GCF of 2. When you factor that out, that leaves you m plus 3. So we want to bring our attention to these factored forms. This right here, this, and that, okay? So in those three factored expressions, we're now going to find the LCM by going through the procedure. We're going to multiply the highest power of all factors. So in order to do that, notice we notice that for m plus 2, the highest power is going to be represented by m plus 2 squared. The other factor that we see is m plus 3. That one is going to bring in an m plus 3. And let's never forget the all-important constants. The only constant we have here is a 2, so that's going to be part of our LCM as well. So for the LCM, we get 2 times m plus 2 squared times m plus 3. Okay. So what we're going to do next now is we're going to learn what we have, use what we have learned regarding the LCM to go ahead and combine rational expressions which have variables in them. Okay, so let's go ahead and use what we have learned about finding the LCM and apply it to combining unlike fractions. So let's start with a real simple example once again of just constant fractions like 3/4 plus 4/5. Okay, as you know, these two are unlike fractions because the denominators are different, so we look for the LCM of the two denominators, which we call the LCD. The LCD is just simply the LCM of all the items involved. So here the LCD is simple enough. It is 20. That is the smallest number that they both go into. So in order to turn 4 into 20, we need to multiply it by 5. So we have to do the exact same to the numerator. In order to turn the 5 into 20, we have to multiply it by 4, and we'll do exactly the same to the numerator. So notice that both denominators are now 20, which means we can go ahead and combine the fractions by keeping the 20 and combining those new numerators, which are what? 15 and 16. So we go 15 plus 16. And when we simplify that, we get 31 over 20, and we are finished with that. So now we can do something very similar with variable expressions. So let's say we have 1 over x plus 1 over x plus 1, okay? So the first thing we'll do is we'll go ahead and find the least common multiple of x and x plus 1 in a similar procedure to what we did just a few minutes ago with the expressions. So here notice we have two factors. One is x and the other one is x plus 1. So to get the LCD, we're just going to multiply the highest power of each of those, which is just x and x plus 1. So the LCD here is going to be x times x plus 1. So we need to make sure this denominator turns into the common denominator. So in order to do that, what's missing? The x plus 1. So we're going to multiply the top and bottom of this fraction by x plus 1. Notice that in order to turn this denominator into the common denominator, what's missing is just the x. So go ahead and make sure you parenthesize this x plus 1 and multiply it by x and do the same on the top. Okay, and we end up with denominators being the same, therefore now they're like fractions, and we can just simply combine the numerators. So the new numerators are x plus 1 and x. So now all we have to do is go ahead and simplify this by getting 2x plus 1 over x times x plus 1. Okay, so we notice that there is no factoring possible on the top, and this is already factored. And there is no legal cancellation possible. We can't cancel that x because it's tied up in this as one term, and we can't cancel. So there's really no cancellation here that's possible. So we are finished, and that's going to be the final answer. Okay, so let's go ahead and take a look at another problem together. Let's go ahead and combine 2 over x minus 3 over x squared. Go ahead and pause your video and try this on your own before you come back and play the video. Now that you're back, notice that the least common multiple of these two expressions is just going to be x squared. They're pretty much the same factor, so we just have to take the highest power of x that there is, and what is that? That's x squared. So that's going to be our least common denominator. So this one is already x squared, so we don't need to do anything to this denominator. But this one is not. This one is x. So in order to turn it into the common denominator, which is x squared, we're going to have to multiply by, I can hear you, some of you say, x. And that's exactly what we do. But remember, if you do something to a denominator, you got to do exactly the same to the numerator. All right, so now both denominators, notice, they're both what? They're both x squared. So that means now we can just what? Combine the numerators. So we get 2x minus 3, and no legal cancellation available, so we are finished. All right, so let's go ahead and take a look at one other example. Let's go ahead and combine these. 4x plus 1 over x plus 5 minus 2 over x plus 10 over x squared plus 5x. You should go ahead and pause the video for a minute again to see if you can get the answer on your own before you come back to play it. Remember, you always have the option of just continuing, but for your own best interest, you should follow my directions when I ask you to pause. Go ahead and pause, try it on your own, then come back. Okay, I'm hoping that you're coming back from a pause. All right, what we're going to do is we're going to first try to find the LCD. But in order to do that, we're first going to factor any denominator that is not already factored. Notice there's not much we can do here. No factoring possible. That's prime. So is this. So this is the only place where a little bit of factoring is possible. So that's what we're going to start with. We won't touch anything else at this time. So 4x plus 1 over x plus 5 does not change, nor does the 2 over x. The only change is going to happen here when we take the x squared plus 5x and factor it. Now notice the only factoring that we have available here is a GCF of x. So that's what we're going to do. We're going to go ahead and factor out the x, and that leaves us x plus 5. Notice how all three denominators are now fully factored, which makes it very easy to find the LCD, because now we just follow the basic procedure which we have, which is just what? multiply the highest power of each factor that we see. Notice we have a factor of x, a factor of x plus 5, and that's it. So notice the highest power of x that we see is just x. Even though x appears twice, we don't need to bring it in twice and say x squared. No, we just need the highest power of x, and that's x itself. And we need the highest power of x plus 5. Again, notice that's just x plus 5 to the 1, or just x plus 5. So the LCD is going to be x times x plus 5. All right, now we're going to go ahead and make sure that each of these denominators become that common denominator. So for this denominator to become this common denominator, it's missing a factor of x. Exactly. So we're going to go ahead and parenthesize it since it's more than one term, and we're going to multiply it by x, and we're going to do the same thing here. Let's go ahead and write it on the left side just to be safe, because we're going to have to distribute that later. So let's just keep it like that. And then this denominator here is missing a factor of x plus 5, so we'll go ahead and bring in an x plus 5. Now you notice all three denominators are what? The same, which is exactly what we want. Remember, you can really only combine like fractions. Now these fractions are like fractions. They each have a common denominator of x times x plus 5, which we wrote here. Now all we have to do is keep that common denominator and combine those new numerators, which are x times 4x plus 1 minus, notice I don't do any distributing at this stage, and you shouldn't either, because that's when you get in trouble. Minus 2 times x plus 5, and then plus just a 10. This one we don't have to do anything with, because that denominator was already the same as the common denominator. So we're basically finished with the combining. The rest is simplifying. So we're going to go ahead and multiply this out. So we're going to get 4x squared plus x. Now we're going to have to distribute the negative 2, so be careful when you multiply the negative. So you're going to get negative 2x minus 10, and then what? Plus 10 over x times x plus 5. Okay, now we have a little bit of simplifying we can do here. Notice these negative 10 and that positive 10 are going to cancel out. So we have 4x squared. These two are just going to give us what? Minus x over x times x plus 5. Okay, it would be tempting to get excited at this point, consider it finished, and then just type that in. Of course, you're going to get the red X if you do. So we're going to go ahead and continue, because there's simplification that's possible. We can factor out an X on the top. So we factor the X on the top. That leaves us 4x minus 1 over x times x plus 5. Now we notice that we have a common factor of x that we can go ahead and cancel out, leaving us a 1 and a 1. So the final answer is just going to be 4x minus 1 over x plus 5. No more legal cancellation is possible, therefore we box it, and that's what we're going to type into my math lab. So we'll look at another example in a minute. That's the end of that example for now. Okay, next we want to look at a special kind of problem. 3 over 2 minus t plus 1 over t minus 2. If you remember from a previous lesson in 7.1 actually, 2 minus t and t minus 2, if you remember, we called it the a minus b and b minus a case. They're related, they're opposites of each other. So in order to make these two denominators the same or find the LCD, we don't actually have to multiply both of these factors. It's simpler than that. If we take either this one or that one, makes no difference, and multiply it by -1, it's going to turn into the other. So that's exactly what we're going to do. In fact, we'll take this one, for instance, and we'll multiply the top and the bottom by -1. Okay, notice what happens now. If I multiply -1, I get -2 plus t, and I can always write the t first. So it's really just t minus 2. See? -1 times -t is t, -1 times 2 is -2. So now we have -3 over t minus 2 plus 1 over t minus 2. So just with that simple move of multiplying top and bottom of this fraction by -1, we ended up making the denominators the same. So all we have to do now is keep the common denominator and combine the numerators. -3 plus 1. And we end up with -2 over t minus 2. And remember, that would be an illegal cancellation, so we'll leave that alone. There is nothing we can do here. We are finished. Notice that in some textbooks, for instance, you may see the answer given as -2 over t minus 2 in that fashion, and that's the same as this answer. So they're both correct forms of the answer. So remember, if you get a minus b and b minus a situation, don't just multiply those. Turn one into the other with the simple trick of multiplying the top and bottom of the fraction by -1. And of course you can do that because -1 over -1 is 1, so you're not really changing the problem, you're changing the way it looks. And you end up with the same denominator. Let's look at one more problem before we call it the day for this section, and that is this one. Let's look at 4 over x plus 3 minus x over x minus 3 minus 18 over x squared minus 9. You have enough information right now where you should be able to handle that. So go ahead and pause the video and try it on your own first. Remember, you're going to want to make sure all denominators are fully factored before you try to find the LCD. So try that and then come back to the video. Make sure you try it first. Okay. Now that I'm hoping you've returned from a pause, the first thing we're going to do is factor all denominators. This one is already prime and simple. So is this. This is the only one where some factoring is possible. So we just go ahead and rewrite the first two denominators. Remember, be generous and leave some space because we may have to multiply top and bottom of some of these fractions by some expressions, and we want to have enough room to do that. So don't write these in a small, unreadable manner. Now this one is factorable, right? Remember, that's a difference of two squares, right? And you know how those factor? They factor as a product of conjugates with the form that we had, which was, if you recalled, I'll write it down here, f squared minus l squared equals f plus l times f minus l. In this situation, your f is x and the L is 3. So that's a simple factorization. It turns into x plus 3 times x minus 3. Now that we have fully factored all denominators, we're ready to go ahead and write the LCD. And of course, for that, we're just going to multiply the highest power of each factor. Notice the highest power of x plus 3 is just x plus 3 itself. And the highest power of x minus 3 is also the first power, so just x minus 3. Now we're going to go ahead and make sure that each of these denominators becomes like the common denominator. This one is already there, so we don't need to do anything with this denominator, but these two need some work, right? Notice this denominator is missing an x minus 3, factor of x minus 3. So make sure you parenthesize the x plus 3 that's already there, and go ahead and multiply it by x minus 3. And remember, if we multiply the denominator by something, we have to multiply the numerator by the same expression. So we multiply that by x minus 3 as well. This denominator is missing an x plus 3. So we go ahead and parenthesize it and multiply it by x plus 3, and we do the same on the top. So we get x plus 3 and x plus 3 over there like that. And remember, this one, this fraction, we don't need to do anything to, because the denominator is already what? Is already the common denominator. So now we just go ahead and keep the common denominator and combine the new numerators. So we have 4 times x minus 3 minus x times x plus 3. Notice how I'm avoiding multiplying in my head because I don't want to make any mistakes. So you should do the same. So now we're just going to go ahead and multiply that out. So we get 4x minus 12 minus x squared minus 3x minus 18 over x plus 3 times x minus 3. We continue with simplifying. So we notice that we get negative x squared, and the two x terms give us plus x, and those two combine to give us negative 30 over x plus 3 times x minus 3. Now remember that we never want to leave anything kind of factoring that may be possible behind. So, and when an expression starts with a negative, remember it's easier to factor if you factor out the negative one first. So if I just factor out a negative from the top expression, I'm left with x squared minus x plus 30 over x plus 3 times x minus 3. Now that looks like a expression I may be able to factor, so I'm going to go ahead and try to factor it. So I get negative, notice that factors as x minus 6 times x plus 5 over x plus 3 times x minus 3. So I noticed that even after I did the factoring, there is no common factor that I can get rid of. So at this point, I can safely go ahead and type that in as my final answer. So given that factorization was not possible, there is another one of these steps that you could also type in as the final answer, and that would be correct, and that would be this one. But notice that it is important for us to try to factor and make sure there is no simplification possible before giving up. So that should pretty much be enough to get you ready for doing the homework. So if you have any problems, again, you can try to get help from Help Me Solve This, but if that doesn't do it for you, then send me an email. Don't forget to give me the set number and the problem number, and I will try to put up a video with the explanation of the problem that you had, and I'll upload it into Canvas. So until next time, take care and be safe. Stay home and make sure that you don't expose yourself or anyone else to this dangerous situation. I'll talk to you guys next time.